Welcome to this explainer. You know, when you look up at the night sky, what do you actually see? For most of us, the moon is just this glowing orb, right? A quiet, lifeless rock silently keeping us company. But today, we're going to synthesize the source material to fundamentally flip that perception on its head. The data actually reveals something entirely different. We are looking at a highly dynamic, notoriously dangerous, and resource-rich frontier that is quite literally constantly in motion. To do that, we're breaking this explainer down into 4 main parts. First, myths of the moon. Second, a brutal dynamic surface. Third, humanity's strange lunar footprint. And finally, hidden resources and the future. All right, let's jump straight into part 1, myths of the moon. So we've all heard the pop culture references to the dark side of the moon. It's everywhere. But looking at the astronomical data, we really have to ask, is it actually pitch black back there? I mean, it's a super common assumption that the far side receives absolutely no sunlight whatsoever. Well, the answer is a definitive no. The moon is what astrophysicists call tidally locked to Earth. Basically, this means it rotates on its own axis at the exact same rate that it orbits our planet. And this perfect synchronization, it didn't just happen overnight. It's the result of billions of years of gravitational friction slowly, almost imperceptibly, applying the brakes to the moon's spin until it perfectly matched its orbit. Because of this intricate cosmic dance, we only ever see one face of it from down here on Earth. But as it rotates around us, the sun is absolutely blasting its light onto all sides of the moon. So yeah, the dark side gets just as much sunlight as the side we see. It's actually only dark to our specific field of vision. Now, comparing the Earth and the moon side by side reveals some really stark fundamental contrasts. Take Earth. We've got a 23.5-degree axial tilt, which gives us our dynamic, ever-changing seasons. The moon? It barely tips the scales with a tiny 1.5-degree tilt. That means it experiences virtually zero seasonal changes. Nothing. Also, Earth is protected by this massive magnetic field generated by its spinning liquid core, right? The moon, on the other hand, has absolutely no active magnetic field of its own. It actually has to rely entirely on Earth's magnetosphere whenever it passes through it. And this matters immensely because without that invisible shield, the lunar surface is completely defenseless against brutal, unyielding space radiation. Oh, and of course, the moon's gravity is merely 1/6 of what we experience walking around here on Earth. Speaking of gravity, it's actually locked in this fascinating, invisible, cosmic tug-of-war. The moon's gravitational pull is actively dragging on our oceans, which creates our tides. But this friction actually slows down Earth's rotation. In return, the Earth's massive counter-effect pushes back, transferring energy that physically extends the lunar orbit. Because of these opposing forces, and this is wild, the moon is quite literally drifting away from us at a rate of 4 centimeters every single year. I mean, over eons, this subtle but relentless drift is going to dramatically alter the tides, the ocean currents, and the very ecosystems of our own planet. Okay, moving right along to part 2, a brutal dynamic surface. So because there's zero atmosphere up there to regulate heat or scatter light, the lunar environment is just wildly unstable. Get this. During an eclipse, when the Earth's shadow passes over the moon and blocks the sun, the surface temperature completely plummets. We are talking about a staggering drop of 500 degrees Fahrenheit in just 90 minutes. That is a violent, rapid temperature shift unlike absolutely anything we could ever survive on Earth. It really makes the lunar landscape an extreme and totally unforgiving frontier. And it gets crazier when we look at seismic activity. The crucial point here is scale and origin. You might look up and think the moon is completely still, just a dead world, but it actually experiences moonquakes. Now, while earthquakes are caused by shifting tectonic plates and typically only last for a few terrifying seconds, maybe minutes, moonquakes are an entirely different beast. They are caused by Earth's intense gravity literally pulling and stretching the solid rock of the moon itself. Imagine standing on ground that violently shakes, not just for a fleeting moment, but for over 30 minutes at a time. This relentless, aggressive shaking turns the surface into a truly hostile environment. But the surface isn't just physically hostile. It's incredibly alien to our senses, too. You probably wouldn't expect outer space to have a scent, right? Well, when the Apollo astronauts brought lunar rock and soil samples back into their ships, they noticed something totally bizarre. See, the lunar surface is completely exposed to space and cosmic rays, causing chemical elements like iron and titanium to oxidize. Once those dust particles were exposed to the oxygen inside the astronauts' pressurized cabins, these compounds gave off a very distinct pungent odor. Almost universally, the astronauts described it exactly like the smell of burnt gunpowder. How crazy is that? And it turns out that same dust is also profoundly lethal. Down here on Earth, water and wind continuously erode rocks into smooth, harmless sand. But on the moon, zero erosion. That means every single microscopic dust particle remains extremely jagged and razor-sharp. It literally tore right into the astronauts' highly durable space boots and severely scratched up their heavy-duty visors. But the real danger is internal. If inhaled, this microscopic shrapnel causes a severe respiratory threat that NASA dubbed lunar hay fever. Medical studies later revealed that these sharp particles are actually capable of completely destroying human lung and brain cells. Which brings us to part 3, humanity's strange lunar footprint. We tend to romanticize our history of space exploration, don't we? But our actual footprint up there is strangely messy. To save critical weight for the long journey home, Apollo astronauts had to leave behind a massive amount of trash. Yeah, humanity's first major act on another world was essentially littering. We abandoned everything from heavy boots to fully functional lunar rovers and retroflectors that were used to beam data back to Earth. But actually, perhaps even more shocking than our trash, is Project A119. During the heightened tensions of the Cold War in the 1950s, the United States seriously developed a thought experiment to blow up the moon with a nuclear weapon. And the reason? Simply as a massive, visible show of force to the Soviet Union. No way, right? Tracking our timeline really puts this bizarre human presence into perspective. So Project A119 was boldly proposed in the 1950s. Then we successfully landed humans on the surface in 1969, and our very last human mission wrapped up shortly after in 1972. But technically speaking, the moon became a human burial site decades later, in 1999. A NASA rover carrying the ashes of the legendary astronomer and geologist Dr. Eugene Shoemaker intentionally crashed right into the lunar surface. To this very day, he remains the only person ever formally laid to rest on the moon. It's kind of a poetic end for a man who dedicated his entire life to studying the cosmos. And finally, let's dive into part 4, hidden resources and the future. So despite the extreme, deadly harshness we've just been talking about, there is a unique and highly valuable water cycle happening right now at the lunar poles. Here is exactly how it works. First, frozen ice on the surface melts during the warm lunar day. Second, it vaporizes and rises up into the highly tenuous lunar exosphere. And third, that vapor travels around the moon until the temperatures drop, freezing right back into solid ice on the dark, freezing surface. For future human exploration, this natural cycle is an absolute game changer. Rovers could eventually harvest this ice, purify it for drinking water, and even systematically convert it into rocket fuel. That would effectively turn the moon into a vital interplanetary gas station for missions pushing much deeper into our solar system. Beyond just water, the lunar surface has been heavily bombarded by solar wind for billions of years. Because the moon lacks a magnetic field to deflect it, this solar wind just relentlessly deposits a highly sought-after, incredibly valuable resource directly onto the topsoil, helium-3. It's a super rare isotope that is practically non-existent on Earth, but the moon holds an estimated 1.1 million tons of the stuff. So why does this matter so much? Well, because helium-3 is considered an ideal, completely clean fuel for nuclear fusion. Mining this could realistically provide limitless, sustainable, clean energy for the entirety of Earth. We're talking about completely revolutionizing our entire power grid. But then the obvious question is, how will we survive long enough to actually mine these incredible resources? I mean, to survive the extreme 500-degree temperature swings, the deadly cosmic radiation, and the constant, totally unpredictable meteor swarms, future astronauts likely won't build their delicate bases on the exposed surface at all. Instead, they're going to take shelter inside lunar pits. These are ancient, completely collapsed underground lava caverns left over from when the moon was fiercely volcanically active. They essentially provide a massive, ready-made natural fortress against the brutal environment above. It gives humanity a perfect safe haven in an otherwise completely lethal landscape. And that really brings us to the ultimate question. The far side of the moon, permanently facing outward into the void, takes the absolute brunt of deep space impacts. Because of this, it features massive, undisturbed time capsules, like the 2,500-kilometer South Pole Aitken crater, which perfectly preserves the history of our solar system's violent, chaotic formation. Think about it. If we have learned this much from just a few brief visits to the visible side, we really have to ask, what other universe-altering secrets are waiting for us in the dark?